Let's do practice problem 15 on page 133, and here it is. It says, suppose the sled runs on packed snow. The coefficient of friction is now only 0.12. If a person weighing 650 newtons sits on the sled, what force is needed to pull the sled across the snow at constant speed? So, let's draw a picture of this problem. We've got, here's what's given. Here's my sled. Here's somebody sitting on the sled. You have to draw just like I do, see? They've got a little hat on. Here's a scarf. All right. There they are. Okay, maybe it's a sled in old Mexico. All right, now, so someone's pulling on it. So here's somebody pulling on it. You don't have to draw the person pulling on it, but I like to draw. Okay, now they're pulling on the sled, and the velocity equals a constant. Now what does that mean? Whenever you see the velocity is a constant, you should think little lights should go off. What does that mean, constant velocity? Oh, you guys are so smart. Way better than my last class. All right, whoop. A equals A? No, A equals 0. All right. Now, it said in the previous problem that the sled weighs, the force of gravity on the sled, what was it, 52 newtons? Correct. And then it said the weight of the person, I'm not drawing these to scale, the weight of the person is 650 newtons. So pretty light sled, so we have to add these together to get the total weight. So this is what's given. And what are we trying to find? Yeah, the force that this kid's pulling on it with, we'll call that the applied force. Or you can call it F sub P for pulling force, or F sub B for the force of the boy pulling. I don't care. I don't even know if it's a boy. All right, so let's solve. Now, this was step 1 of the procedure. Now, this is a problem involving force, so I'm going to draw the free body diagram. So I'm just going to draw the sled and the person sitting in the sled, you know, as one thing. So we've got the force of gravity here. I'm going to call it M times G. You don't have to, but I'm just going to add these up. This is 702 newtons, isn't it? Why, thank you for paying attention. All right, and then now the sled is not sinking into the snow and it's not flying in the air, so we have a normal force that's supporting all that weight. Then we've got somebody pulling on it. There's my applied force, and then I've got a force of friction holding it back. Now, are there any other forces in this problem? No. And by the way, every problem is a little bit different. Sometimes you don't have an applied force. If nobody's pulling or pushing on it, there's no applied force. You know, you could have a sled that's sliding to a stop, you know, or something like that. In this case, the force of friction would be the net force. But this is the problem I'm given. Now I'm going to so this is step 2. Step 3, identify your X and Y direction. Now, step 4, we can apply Newton's laws to this problem. Let's sum the forces in the X direction will be equal to MA in the X. I always write this out, and then I put an underline, and then I do all my X direction work underneath here. And I say, and I look at my free body diagram, and I go, okay, I've got FA going to the right. Now to the left is the force of friction, and to the left is negative, so minus the force of friction. is equal to ma. Now, what is the acceleration in this problem?
0.
Thank you. So what this tells me is that my applied force will be equal to my force of friction. In this problem, that's true. Now, I could give you a problem where there is acceleration, in which case the applied force will be equal to the force of friction plus ma. Okay, so you have to, it all depends on the problem. So now I need to figure out my force of friction. Well, the force of friction is equal to mu times the normal force. Now this needs to be in your equation list. On your equation, okay? And so, well, I know what mu is, that's given. Oh, I forgot to write it down on what was given. What was it? 0.12. Sorry about that. Mu equals 0.12. And so I'm going to, force of friction is equal to 0.12 times the normal force. Well, what is the normal force equal to? Now, I'm just going to say it's 702 newtons because I can look at my free body diagram and say, hey, there's no acceleration in the y direction, so the weight and the normal force have to be equal but opposite. So the normal force is 702 newtons.
Did you call that the net force?
The net force in this problem, I think the question is, would I call that the net force?
Yeah,
No, that is the normal force. The net force in this problem is 0. There is no net force because there is no acceleration in this problem. Okay, good question. A lot of people think this N stands for net. It doesn't. It stands for normal. If I'm going to write out the net force, you will see me write out the whole word, net. Okay, but the net force in this problem is equal to 0. Well, look, sum the forces in the y direction equals ma in the y direction. Why am I doing this? Just to be thorough. The normal force minus 702 newtons equals 0. Why does it equal 0? There's no acceleration. ma is 0. When I add up all the forces in the y direction, I get 2 of them. Normal force, the weight. I have to subtract because this is in the negative y direction. And all this tells me, oh, okay, the normal force is 702 newtons, which I already knew. So what does that tell me is true about the force of friction? What's 0.12 times 702? 84 newtons. And that means that my applied force is equal to 84 newtons. In other words, I have to pull on this sled with 84 newtons to get it to slide across the snow with at constant velocity. Okay? This is a good problem to understand. That is all.